Alright, this is the end of the road for this week. This is part 3 on 6-3. First of all, we're going to be solving some equations along with graphing. Graphing is fun and all, but mostly this chapter is going to be about solving these logarithmic and exponential equations. So, we're going to learn the rules one at a time and just kind of apply them one at a time through the rest of this chapter. So our first rule is, if a to the u equals a to the v, then u equals v. Write that down, circle it, highlight it, okay? Here's what's happening. I have the same base, but it's to different exponents. If the bases are the same, then the exponents are equal. That's what it is. In words, if the bases are the same, the exponents are equal. So, if I have something like this, 7 to the x equals 7 to the third, if the bases are the same, so the exponents are equal. So if I set them equal to each other, I can solve and get x equals 3. How could this go wrong? Look at this guy. I have 2 to the negative x equals 16. But Miss Noble, the bases aren't the same. You are correct. Very good observation. But could I take 16 and rewrite it as 2 to a power? Yes. Now you can guess and check in your calculator, or you can think about your powers of 2. 2 to the first is 2, 2 squared is 4, 2 to the third is 18, 2 to the fourth is 16. So I'm going to change that equation. So now it's written 2 to the negative x equals 2 to the fourth. The bases are the same, so the exponents are equal. So if negative x equals 4 and I divide both sides by a negative 1, it just changes everybody's signs. So x equals negative 4. Woo! Alright. One more of these. Oh, I see 3's on both sides. Let's take a closer look. This is 3 to the x plus 1 equals 1/3. I see the 3 in there, but how do I make it 3 to a power? What exponent is going to be up there? 1/3 is a negative 1 exponent. If you don't remember that, look in your notes from the last lecture. That's what we wrote as our first one, 6-3 part 1, where we wrote down our initial rules for exponents. That's why we did that. Now the bases are the same, so now the exponents are equal. I can subtract 1 from both sides, negative 1 minus 1, negative 2. So that's how that rule works. Our whole goal is to get the bases to be the same. No problem, right? Let's try this one. There we go. Okay. I know they're fractions. You're okay. This is 1/5 to the x equals 1/25. I know that 5 and 25 are related somehow, so I'd like to rewrite this. Ugh. You know what? You might be happier if we rewrite them both. So let me do that way, okay? If we had time to talk that out, it'd be different, but let's just write it. 1/5 is a power of 5. It is 5 to the negative 1. And 1/25, 25 is 5 squared, so 1/25 is 5 to the negative 2. If 5 squared is 25, 1 over 5 squared is 5 to the negative 2. Okay? Alright, so now the bases are the same, but look at this business. What do I do with an exponent power to a power? I multiply them. That's what. So I have negative 1 times x is negative x. Now the bases are the same. Hallelujah. We're going to solve for x. Divide both sides by a negative 1. Whew. You love fractions, and you know it. Don't even pretend you don't. Let's look at this guy. No problem. We love this. Alright, so I see 5 and 125. I bet they're related somehow. Could I take 5 to a power and get 125? Well, you can. Go in your calculator and check it out. This side, this is x squared plus 8 in the exponent, by the way. It is what it looks like. This 125 is 5 to the third. So now I'm taking and replacing 125 with 5 to the third. So when I take these exponents, power to a power, I multiply. So this is really 5 to the 6x. Multiply. Now my bases are the same, so I have x squared plus 8 equals 6x. Now I know I need to solve this thing, but it is a quadratic. That means everything on one side equal to 0 and then factor and solve or use the quadratic formula. This one's going to factor for us, I bet. I just have that feeling. So I'm moving the 6x over so it's equal to 0, and we're going to bust out a box or just factoring, guess and check, and I want you to factor that up. Well, did you do it right? How exciting! We have two solutions for x, 4 or 2. And both of those are going to work. They're both just fine. Okay? There's no domain for exponential functions was negative infinity to infinity, so everything works. Alright, I have one more because people kind of panic when they see e's in there, but e is just a number just like any other number, it's just 2.72, right? So we're not going to panic. I see that both of the bases are e, which is great news for me because that means the exponents are equal to each other. So we're just going to solve for x. I'm going to move this x over so all the x's can be together. And then I'm going to divide by 4. And 2 divided by 4 is 1/2. Oh, see, that was nice, wasn't it? How pleasant. Okay. This will probably be a section where you will do all of that part on Pearson, but I'm going to go and look at it anyway. So, that's it for the week. I think that was enough, huh? Should be a good quiz going on this week, too. Or next week over some of these things. Yeah, we're getting into the nitty-gritty. We're almost there, guys. Hold on to your hats.